First, we want to find the total amount of snow between midnight and 6 a.m. So you take the integral to add up all the snowfall from midnight to 6. Then for B, we're trying to find the rate of change at 8 a.m. So you take the amount of snow that falls and the amount of snow, and subtract the amount of snow that was removed to find the total rate of change of snow. Then for C, we're trying to find the amount of snow removed from the driveway after midnight. So for what we're doing for each interval is, eventually I'll write it, but you're taking the initial amount shoveled at the beginning of the interval and then adding the integral of the total amount of snow shoveled from or during the interval, just for each one. So here you can see me just finally putting them all together because there's a lot of them. Then for D, we're just trying to find how much snow is on the driveway at 9. So we're going to write the integral of the total snowfall until 9 a.m. and then subtract that, and subtract the total amount of snow removed, and the difference shows how much snow is left. So we need to find the rate at 6, so you just take like e of 7 minus e of 5 over 7 over 5 to get the slope between them to get the estimate of e prime of 6. So then we have to find a trapezoidal sum of 4 sum intervals. So you have to multiply it all by like 1/8 because that's the like average thing. So then you have to multiply the height times base 1 times base 2 divided by 2, and then just add them all together, and eventually you'll get the answer. So then eventually you get 10.688, which is the average number of hundreds of entries between 12 p.m. and 8 p.m. So then to find the total entries left, you take the total entries at 8 p.m. and subtract basically the total amount of entries processed from 8 to 12 p.m. and that'll give you the difference will give you the 700 entries that are left. So then at P of T, you have T equals 9.14 and T equals 10.06, which are endpoints. So you'll use those in where that's where like f prime equals 0, sorry. So you plug in the endpoints into a table, which I have not written yet, but when I write the table, you'll know. So yeah, you just write those in and find the corresponding y value for each one and find which value is the highest, and that's the maximum processing rate. So for this one, we're trying to find the speed at time t equals 3. So for that, you just need to do the square root of dx dt squared plus dy dt squared. So, or at time t equals 3, and evaluate there. So then I'm just rewriting it with the actual stuff, and I also found dx dt from the first equation x of t, which is just 2t plus 4, and then I just evaluate it to eventually get to 2.828 meters per second. Then for B, we're just trying to find the distance traveled from 0 to 4 seconds. So I just set up an integral from 0 to 4 of the square root of dx dt squared plus dy dt squared, which will eventually plug it into the calculator and you get 11.588 meters. Then for C, we're just finding where the tangent line is horizontal, so that would be at where dy dt equals 0. So you just plug that into the calculator and you find that that's at t equals 2.208 on the calculator. And because x prime of t is of 2.28 is greater than 0, the particle will be going right. So then for D, for the first part, for all of it, it's that x of t equals 5. So the first part, we can know that at x equals 5, t equals 1 and 3. So then for the next part, we're trying to find the slope. So you just do dy dt over dx dt of t equals 1, which is 0.432, and then you do the same at t equals 3, which is 1. Then for the next part, we know that y of 1 and y of 3 are equal, so then you're trying to find y of 2, which is at the point 3 plus 1 over e, and then you do the integral from 2 to 3 of dy dt, and that'll get you 4. So for A, we're just trying to find the area of R, so you set up an integral from 0 to 9, and then you have y of 6, which is like what's bounding it, and so you do 6 minus the equation 2 root x dx, which then you evaluate it and you get 18. Then for B, you're trying to find the volume at y equals 7. So you have to do them because you're rotating 7 minus 2x. But the 7 minus 6 is added because you're not rotating that part, or it's not actually part of it. So you have to subtract it from the actual volume. Then for C, we're finding the rectangular cross sections of these. So you have to make the y into x. So you end up getting x equals y squared over 4. And the the length is 3 times the base, sorry. So you have to multiply that by 3 and then multiply it by the other one. So you get 3/16 y fourth, and then you just have the volume equals the integral from 0 to 6, and then a 3/16 y4 dy. So for A, we're just doing simple, Euler's method. So you're starting at x equals 1, and then you plug, or we know that f of 1 equals 0. So you plug that into the dy over dx. So you'll get the slope, which is 1, and then you plug that into the equation, you get negative 1/2 as the y after you plug in 1/2. And then you also plug in negative 1/2 to the dy dx, and you get negative 5/4. Then for B, you have to do, we're trying to find the limit of f of x over x cubed minus 1 as x approaches 1. So we're proving that they both go to 0 separately, so we can do L'Hopital's. And then eventually, after you do L'Hopital's, you just plug it in, you get 1/3. Then for C, we have to do the particular solution. So you have to move the variables to their respective sides. So you have dy with 1 minus y equals dx, and then you take the integral of both of them. So when you take the integral of both of them, then you have to add the plus c, and we have the initial condition that f of 1 equals 0. So you plug those in, and then you'll get to c equals 1. So it's c equals negative 1, but then you do e to both sides to cancel out the ln, and then you rewrite that without it, and then you move the 1 to the other side, and also you move the negative to the other side to simplify it even more. So for the first one, you're, just using the Taylor polynomial stuff, and you have to write the non-zero terms for it. So I just wrote those out first. So for this one, we have that f prime of 0 is the coefficient of x in the Taylor series for f, about x equals 0. So that means that f prime of 0 has to equal 0. So then I wrote out like the Taylor polynomial on that part, and then that's the coefficient of x squared in the Taylor series for f about x equals 0. So that means that f double prime of 0 has to equal 1 over 12. Because of the second derivative test, f has a relative minimum at x equals 0. Here you can just see me writing out the fifth degree Taylor polynomial for g about x equals 0. So then we have to find out like why it's different, you know? So the Taylor for g about x equals 0 is a value at x equals 1 is alternating, and the terms decrease and the absolute value to 0, so we know that absolute value of g of 1 minus 37 over 72 is less than 1 over 5 times 6 factorial is less than 1 over 6 factorial.